You're listening to Electrician Live with your host, Paul Abernathy.
Well, hey everybody, welcome to Electrician Live. My name is Paul Abernathy, your host as always, and thank you for joining the live stream here on Saturday night at 8 p.m. Central Standard Time. Hopefully you join us each week where we have interesting topics on all things electrical. Sometimes we even have special guests. Hopefully you joined us last week when we had the people from Siemens as a guest on the show. And that episode is available up on our YouTube channel. That is youtube.com/Master the NEC, as you see written on the screen. Well, when I say written on the screen, also all of you out there that listen on our podcast, obviously I have to paint a mental picture anytime we do these streams that I also have people following along over on our video channel. So I'm going to encourage you to also venture over to our video channel if you ever get a chance. Again, it's on YouTube, and it's youtube.com/Master the NEC, all one word. And make sure you subscribe and you hit that little bell so that you get any future notifications anytime we go live. Now, sometimes I go live during the week where I do exam prep course training. Again, it's a great opportunity for you to join us and be able to ask questions about the National Electrical Code and get some insight on it. We'll joke around, and I'll try to paint some pictures of things to help you understand the code a little bit better, because you need to know this stuff to be successful in the trade, not just to pass an exam. So that's why I do it. I also remind all those out there that are listening to our Electrician Live that we also have Facebook pages, the Master the NEC, that you can join and post questions. But we also have our exam prep forum, which is Master the NEC Exam Prep. So hopefully you check that out as well over on our Facebook page. And of course, we also have Instagram at Master the NEC, Twitter at Master the NEC. So we have a bunch of other social media platforms that you can ask questions, post things, and interact with us, and we're here to try to help you as best we can. Okay, so today's episode, we're going to kind of dig into the grounding electrode systems, and we're going to more talk about electrodes today and kind of examine it a little bit in this episode. Now, for those that are over on the podcast, again, our podcasts are available on Deezer, iPod Radio, Spreaker, Spotify, iHeart. I mean, there's tons of ways you can listen to these podcasts. So hopefully you get something out of those, and hopefully I can convey the message mentally, because obviously if you're listening on a podcast, you can't see it visually. You'd be surprised the number of listeners we have on our podcast. It by far outweighs the number of subscribers we have on YouTube, and I'm not sure why, but again, people like podcasts these days. So we're excited about that. And again, this whole show was actually conceived as a podcast, not a video cast. But again, it's kind of morphed into both. And so we try to do both the best we can. All right, so we're going to jump right in it and talk a little bit about grounding electrode systems. Also, if you just came from our 3-hour webinar, then you're an expert now at all the things that we talked about when it comes to the grounding electrode system. And, of course, that video is still going to be available for you to watch at a later date, but it's only going to be available to those that subscribe to our YouTube channel. So it's a monthly fee that you subscribe. And all of our 2020 NEC code changes and 2020 training for the NEC is all part of the subscription program. It starts at $4.99 and goes all the way up to $14.99, depending on your flavor. So check that out if you want to be a supporting member over on our YouTube channel. All right, let's kind of get into the presentation today and start what we all came here to do, and that is not the one that I want to be on. So let's see if it works here. Okay. Buttons are all messed up as normal. So what we're looking at is, if you have your code books and you're following along, is we're looking at 250.50, which is where we kind of start this journey in the grounding electrode systems. So 250.50 talks about grounding electrode systems. And it says, all grounding electrodes described in 250.52A1 through A7, and we'll look at those, that are present at each building or structure served are required to be bonded together to form a grounding electrode system. So sometimes that gets lost in people when you say, okay, if I have ground rods and I have a ground ring and I have a plate, that they all have to be bonded together. And there's certain ways that we can do that, but the core fundamental is that if they're there, if they're present. Now, it used to be years ago, it says if they were available. But now it says, well, if it's present. So a great example of that is a UFR ground. So a UFR ground is a rebar that's in the footing or footer that's in contact with the earth of a building. And it has a rebar in it, and it's encapsulated in the concrete. And it's in contact with the earth. Now, this was done many years ago by a gentleman named Herb Ufer, and it was kind of his testing, his concepts in areas where it just had low moisture. And so the surface material, the amount of moisture that the concrete could hold in conjunction with the rebar together kind of formed a inherent electrode that typically is something you would have in building construction anyway. So it's already there. So when it comes to buildings that actually do have this, and it has to be in contact with the earth, of course we'll cover all that, but in order to be an electrode, it's got to meet all those caveats. And at the end of the day, that is present. It is there. It is part of the construction. So I have to utilize it. And so a lot of times people will put other things like rods, which they don't have to because the UFR would be enough to suffice. But they'll have other things there, and they all have to be tied together. It all has to work as one system. Okay? So if none of these electrodes exist in A1 through A7, for whatever reason, then you're going to add the electrodes that are given to us in 250.52A4 through 8, or it's A4 through A8, and they're required to be installed and used. Now, the interesting thing is a lot of these in A4 through A8 used to be called man-made. Okay, we have to add them. Whereas A1, A2, A3 typically were inherent to construction, whether it was an underground water pipe in contact with the earth for 10 feet, or it was the concrete encased electrode, those type of things, or building steel that's in the ground, in-ground steel. All those things were kind of inherent to construction, so we didn't have to make them. All right, it was inherent. Whereas A4 through A8 are kind of things that we are adding after the fact, or we have the ability to add after the fact. So we've got A1 through A7, that's your charging statement, and then we say if none of those exist, then we're going to have to install something, and we could utilize A4 through A8 to meet this requirement. Okay? That's what we're talking about here as a general statement. Now, exception. Concrete encased electrodes of existing buildings, okay, of existing buildings are not required to be part of the grounding electrode system if the steel reinforcing bars or rods are not accessible for use without disturbing the concrete. So this is kind of an important exception because I could have a building that has the slab and they come in and do some kind of change or remodel and the service changes, whatever, and now you have somebody say, well, the rebar, the concrete encased electrode, it's present. It's already there, but it's existing. And you're looking at it going, yeah, but if I were to try to make that connection, then I would have to chisel up the rebar of the concrete to find the location, for one, and two, it could undermine the integrity of that foundation. And if that's what comes into play, then you have this exception here that says no. So if that's the case, then I'm going to have to find an electrode other than the concrete encased electrode. And again, I've got a list of them. And probably in this case, it's going to bump us into A4 through A8 as our options, right? But I do have options. So again, this is an exception so that I don't have to disturb the existing foundation in the footers to make that connection, right? All right. So if you look at this screen here, you've kind of got a myriad of all the systems, and we'll kind of walk our way around these so that you get a better idea as we're going to kind of discuss them. And you see the numbers that are up in the upper right. So let's kind of look at this. And again, I should mention that all of these images and all this information is out of our grounding and bonding series. So again, I encourage you, if you really want to know, and this is just a taste, if you really want to know grounding and bonding, then I encourage you to think about jumping on our grounding and bonding series. It's available. The 2020 edition is out, and it's available over on masterthenec.com. So check it out under our courses, and you can find out more about our grounding and bonding. Again, grounding and bonding fundamentally is something you just need to know. You really do, because there's so many things that can go wrong in grounding and bonding, or people can take it too far and you create a hazard that doesn't manifest itself until it's too late. So we really need to be smart. And grounding and bonding is one of the larger articles, 250 in the National Electrical Code, for a reason. It is very complex for many people to take hold and grasp and understand. So I encourage you to check out that course. It is a great course and well worth the money in the investment. All right, so let's kind of walk our way around this picture here. Number one is metal underground water piping. You see that depicted by the number 1 on the graphic. And it's going to be in contact with the earth 10 feet, and that is going to be utilized as an electrode. And the point that it comes into the building, up to 5 feet, is where you would make connections to that water pipe in order to be able to connect other electrodes and things like that. Okay, so that's number 1. Number 2, if you notice that's the steel reinforcing beam that comes down to the slab, but it's in 2 pieces. So you have the piece that's literally driven in the earth. And it could be encased in concrete or physically driven into the earth, so it is physically in contact with the earth. So that is called a metal in-ground support structure. Now, ironically enough, it makes connection to the building frame, but the portion that is actually driven into the earth is the actual electrode itself. Okay? Next is number 3. As you're kind of going around, you see number 3 that's in the slab. That is your concrete encased electrode. And it's 1/2-inch rebar, at least 20 feet, continuous. Of course, it could be 20 feet of 1-foot pieces connected together. But again, cumulatively has to be 20 feet of mass in contact with the concrete that is in contact with the earth. We'll talk about all that, but that's an example of electrode. Now, you notice that 1, 2, and 3 are typically inherent in construction, right? Whereas 4, 5, 6, and 7, and in 8 we don't show here, that is another allowance. But the concept here is all of these, the importance of this is you have some that are inherent, right? And then you have some that are really not and that you have to install. All right, so let's look at them. And so number 4 is the ground ring. So if you look at number 4 on the screen, the ground ring has to encircle the structure, okay? And it doesn't go halfway around. It literally has to encircle, okay, the entire structure in order to qualify as a ground ring. And we'll talk about the details of the ground ring and the minimum size, 2 AWG, copper. We'll talk about that, but you just need to understand that's what it is. Then you look at 5, which is probably the most common used, and that is ground rods. But of course, it's ground rods and pipes, okay, as an allowance here. So again, you see this is driven into the earth, and we'll talk about it, 8 feet. And if you have 2 of them, at least 6 feet apart, we'll talk about that. But ground rod, again, is one of the most common grounding electrodes that's utilized today. It's just simple to just drive a ground rod. All right, then you get into number 6. Now, number 6 is unique because there are other listed grounding electrodes. And they are typically made, and you would put a certain type of chemical in it, and it would leach out into the ground and make the ground around it conductive or a better conducive to dissipate any lightnings that would come in. So this is a made system, but it's a listed. Now, when we say other listed grounding electrodes, this is a catch-all because other listed grounding electrodes could come into play that manufacturers can produce, and they can get it listed, and it can be utilized as a grounding electrode. But typically this one has an access to it because over time you have to refill it with its chemicals inside of it. And they have to install this into the ground. It's kind of like a vessel, and it's in the ground. Okay. And then number 7 is the plate, as you see here. So the surface area of the plate in contact with the earth. I do not see a lot of plates, but we'll talk about plates. But that's typically what you'll see here. And it is in contact with the earth. And so, okay, so this kind of gives you an overview of the ones that we're going to be talking about today. Now, 250.52a, electrodes permitted for grounding. Okay, what's permitted for grounding? Okay, using the grounding electrodes in this section become mandatory due to the requirements of 250.50. Some electrodes are traditionally installed by other trades, like I said, that you've got other trades that would probably install the UFR, that would install the in-ground steel, that he would install the water pipe, okay? So, however, the electrodes A4 through A8 are often installed by the electrician itself. Okay? So there is a difference. Sometimes you can get away with it if somebody else has already installed it based on another trade. The water pipe for the plumbers coming in, or the in-ground steel for the building, or depending on the building type, then you can get away with those things and it might already take place, right? So, again, different things to think about. But again, A4 through 8 typically is what the electrician will actually install. Now, some installation requirements are contained in the description of the grounding electrodes. So, a lot of when you get to A4, A5, A6, A7, you'll also get installation requirements that are going to kind of be all bundled in there together that you have to follow when you're installing these different types of electrodes. So let's kind of start out with A1, metal underground water piping. Now, this is a lot of information on a graphic. So again, bullet points are going to help serve us a little bit here. And again, this all comes from our grounding and bonding series, so I encourage you to check it out. If you're interested in it, because again, really great graphics, and it's a extensive program. This is just unit 3. There's multiple units in this program on grounding and bonding. We cover everything. Now, let's talk about this metal underground water pipe. Very rare today, but it is required to be used if 10 foot or more in direct contact with the earth. Again, then it would be present. So if I've got a metal underground water pipe that is 10 feet or more, and it's going to be in contact with the earth, then it is present. Then it has to be utilized. People want to ignore it, but it's there. It has to be utilized. Now, good news is probably more often today, nobody's using the metal water pipes in the ground. Everything's going to be plastic or something like that. Okay, but if you have copper water lines running in the ground, then there you go. Now, interior metal water piping located more than 5 feet from the point of entry is not permitted to be used for connection purposes. Okay? Now, there is allowances for that. If you're in like a commercial building, then you can see the entire length of this, then it'll let you make a connection over 5 feet. But I like to keep it very simple and say that, look, within 5 feet is the point where we can make bonding connections. The electrode is out in the ground, but the portion that comes into the building up to 5 feet is typically where we would do bonding applications, all right? So keeping that in mind, that's that piece that comes in. Now, over 5 feet, there is some allowances for that, but they're very specific in the code, all right? Now, if this piping goes into the wall somewhere and you can't see it anymore, then you're going to be restricted to the 5 feet. So there are some allowances, but you have to read those. We're going to probably not dig too deep into that. Now, you'll notice in the graphics some important things. You have to maintain the integrity of that 10 feet or more in contact with the earth. So if I have a servicing meter, then it says bonding jumper is long enough for servicing the meter without removal of the jumper. So I don't want to lose the integrity. So I have something that's going to break that connection in contact with the earth in our measurement of 10 feet. And maybe I have a water meter in the way. I'm going to have a bonding jumper on that so that meter could be serviced and I don't lose the integrity of the 10 foot or more in contact with the earth. Okay, so that's going to be a bonding jumper. And again, got to be long enough to facilitate the removal of the meter and not inhibit the 10 feet or more in contact with the earth. Okay, and again, you also see on the slide, it says no part. Those that are over on the podcast, I'll describe these to you. We have an underground water pipe and it has a meter that is imposed in the middle of that, and you just have to make sure there's a jumper on it because the meter could be removed and you break that connection between the one part going in and one part going out. Okay, and then it shows it coming into a building, and the code illustration says not part of the grounding electrode C250.68C1 for use as bonding or grounding electrode conductor, where again it goes beyond 5 feet under specific rules, and you have to follow those rules. Okay. So the next thing it says, let's look at 250.52A2, and that is the metal in-ground support structure. Now, my hope is that everybody over in the podcast have cracked open their code book and are kind of following along as I read these things, because that's the best way to really understand it. Sorry about that. Didn't mean to drop down on you. It's the best way to understand what's going on when it comes to all of these aspects. Okay, so make sure you're following along with that. All right, so 250.52A2, metal in-ground support structure. Methods of making an earth connection of the metal frame of a building or structure as described. It requires direct contact with the earth, concrete encasement, or by connection to concrete encased grounding electrodes. Once a recognized grounding electrode, it can be used to bond other electrodes. Okay, so let's kind of look at what we're talking about here. So here you see a picture. It's in-ground support structure, and you see what it looks like. And you'll notice the one on the left is encased, and you'll notice on the one on the right that's not encased. And for those over in the podcast, what we're showing is the actual I-beam, for example, that was driven down into the earth, and one that's in the earth that's actually encased in concrete. And these are in-ground supports for the actual structure of the building. Okay? So, now we have that bolted to the portion of the framing that's above the ground. Okay? That's the above ground structural metal as permitted to serve as a grounding electrode conductor. Right? But the portion below grade is the actual electrode itself. Okay, so we have some allowances in 250.68C2 for using the metal that is above the structure to be able to bond. In our graphic, we show a connection being made probably by drill and tap or exothermic weld, and it's probably heading off to other electrodes more often than not. But in this case, the electrode is the portion in the ground. The portion above the ground is serving to extend that connection and acting like a conductor, if you will. Okay? The portion that's in the ground, one or more metal in-ground support structures, indirect contact with the earth vertically for 10 feet or more, with or without concrete encasement. Okay? So you don't have to have the concrete encasement. Sometimes they literally drive these into the earth. And then sometimes they can't go deep enough, so they'll drive them down, but then they'll dig them out and they'll put them down and then they'll encase them in concrete. Either way, we're looking for that 10 foot or more in contact with the earth. Okay, vertically. Now, that was pretty simple. The next one we move on to is our concrete encased electrode. Typically, this gets done, and we don't really think much about it as electricians. We're just kind of moving in. And for those that are on the video stream, I apologize. It looks like I am right in the way. So I will duck myself out here for a second. So what you've got here is 250.52A3. Now, 250.52A3 is dealing with concrete encased electrodes. Now, remember, we're still in item 1, A1, A2, and A3, so these are inherent with the construction pretty much. Now, I will say this. If you have a slab that does not have the rebar, if you have a footer or foundation that has a vapor barrier that does not allow the concrete with the rebar in it to come in direct contact with the earth, then you do not have a concrete encased electrode. And if you do not have one, then it doesn't come into play. It is not present. You with me? So at that point, you're going to have to go to other options. And luckily for us, we have other options. I would love to use the concrete encased electrode as an electrician because it's already there. But again, depending on the situation and what you're dealing with, it may or may not be present. Okay? Now, 250.52A3, CEE, or people call it U for ground. Let's read it. It says, required to be used where present at the building or structure served. Again, we kind of talked about whether something's constituting present or not. If there's a vapor barrier, I have seen occasions where the AHJ will make them cut an opening in the vapor barrier for the concrete to become in contact with the earth, and then they can use the concrete encased electrode. I have others that would not permit it, depending on where you're at in the country. They want that vapor barrier. They want to maintain the integrity of that vapor barrier. Okay, then it would not be a concrete encased electrode. Then you're going to have to do something else. Kind of a shame, but it is what it is. It says use of these electrodes were pioneered in the early 1940s and the U.S. Army, and again, perfected in the 40s, 50s, and 60s. And all of this information, be honest with you, is a really, really, really good read. But you get access to this in our grounding and bonding course as an annex, where you can kind of read the history if you're kind of one of those history buffs. So we do provide that so you can kind of read what was done and how it was done in case you want to do that. Now, if you look at the graphic, and again, those in the podcast, I will do my best to describe it. And if you are listening to the podcast and you really want the benefit of the graphics, no worries. You can stop right now and go over to our YouTube channel and watch it at youtube.com/Master the NEC. And you'll see and notice that it's live, and you can jump on there and follow along. All right, so what we've got is a picture of a foundation. It's a footer, and it has the rebar. And let's kind of read it. So what constitutes a concrete encased electrode? Well, it's encased by at least 2 inches of concrete, so the rebar is encased. Okay, it should be inherent in your foundation if you're using rebar anyway, but it's there. It's located horizontally within portions of the concrete foundation or footing in direct contact with the earth, or within vertical foundation or structural components in contact with the earth. So it can be horizontal or it could be vertical. Okay, not a problem, either or, but we have some length requirements here. And what does it say? It has to be 20 feet or more of 1/2 inch or larger electrically conductive reinforced bar or bare copper, 4 AWG or larger. So I could lay 4 AWG copper, 20 feet of it in the footer, or I could have 20 feet of 1/2 inch rebar in the footer. And the other misconception people have is it has to be 20 feet. It does have to cumulatively add up to 20 feet, but it could be 21-foot pieces, and they just get overlapped. Okay. Now, we're not talking about bundling together and throw them in a trench, okay, because it uses the terminology length. And based on all the testing that was done, we're talking horizontally or vertically. These pieces have to have contact in surface area in contact with the earth. Now, people want to get into semantics, but the reality is it's all about the surface area. If I bundle a bunch of rebar together, then the ones that are on the inner part of this bundle are never going to come in contact with the earth, and that's what we're trying to do in order to get the earth resistance as low as possible. There's no testing for this, unlike ground rods where you got to be 25 ohms or less, or you got to have a second one. There's no testing for this. So we want it to be the best it can be. So again, you can overlap them, but you cannot just bundle them all together and throw them in a trench. Okay, I would not endorse that application, even if you want to read into the semantics of the code. It uses the term length in the language for a reason, and then you just got to go back and read the study and realize the importance of the study to understand. And again, we're gonna hinge on that term length, and is the key. All right. So those are the things that are in place. Now, again, we're just going through the electrodes first. It says 250.52A4 now, ground ring. Ground rings are very popular with towers and things where they're very susceptible to lightning. Again, I guess the engineers believe that is one of the preferred methods. However, they always seem to do the ring and plates or something else, or triad ground rods or whatever they want to do. But let's talk about the ground ring. Now, the ground ring, as I said before, has to circle the building or the structure. So it has to circle it. It can't half moon it. It can't go halfway around it and get that 20 feet and stop. It has to encircle it. So it might be more than 20 feet, but it has to be encircling the entire building or structure that it's being utilized for. It has to be in direct contact with the earth. Okay, so that's important, direct contact with the earth. It has to consist of at least 20 feet of bare copper conductor, not smaller than 2 AWG. Now, can it be larger than 2? Absolutely. Is it required? Not required to be larger than 2. But again, engineers can specify it for whatever reason that they would like it to be larger. And as an electrician, I'm going to have to follow the design. I can argue with them, but if this is what they want, then this is what I'm going to give them. This is what they want. Okay? Now, how deep do I install it? This is an example of it giving you information inside of the language, the burial depth is not less than 2.5 feet. Okay, and that's also covered in 250-53F. So that needs to be not less than, so it's going to be at least 2.5 feet down as it encircles the perimeter of the building or structure. Again, I don't see a whole lot of ground rings. I see them sometimes at test facilities because it makes for a convenient location to connect onto as it goes around the building. I also see this at towers and things like that, but usually that's about the extent of where I see these. Now, 250.52A5, rods and pipe electrodes. Obviously, the more common electrodes that you're going to run into. People drive ground rods all the time. I don't see that much people using pipe or conduits for this, but typically it's going to be ground rods that do this. So, ideally, installed below permanent moisture level, probably something we don't see very often. Most people will drive it to the ground, or they'll leave a piece of it sticking up. Theoretically, you don't have 8 foot in contact with the earth that the code requires. But again, most inspectors are probably not going to give you any grief. If it's up too high, then I'm going to make you protect it from impalement or damage. Okay, and if I have a clamp on it, like an acorn clamp, again, they can come loose if people are banging into it, or you're mowing the lawn, or you're doing something, they can come loose. Probably not a good thing. So again, we have to protect that connection. So again, most people don't realize that the code says it has to be installed below the moisture level. You're going to have to know that in your area. Typically, when I did mine, just kind of a touch point for those that are listening on the podcast or in the video stream, is that I used to take the shovel and scoop out, down about a foot, about where I was at, that I was driving. So then I drove my ground rod there. Now, of course, I always used this, kind of funny. I used to always take a piece of cardboard and slide it over the actual end of the ground rod and push it down about a foot or so down from the end. And then I used to use a hammer drill with an attachment and put my hammer drill on it and let that drive it down. Hopefully it drives straight down. If not, you have options, but hopefully that's what happens. But I also, I used to do that so that I can put the clamp on it and let it slip down, because if you're using sledgehammers, you're going to mushroom out the end, and it's going to be hard to get a connector on. And so, again, that's kind of a tip. I do that. People that have done this before realize that. When you use a hammer drill, it doesn't tend to mushroom out. And there's a reason that ground rods are tapered at the top, so that it mushrooms out evenly. I can always tell when somebody's cut a ground rod because it'll mushroom out and it'll have big gaps in it. That tells you that they cut it off. It doesn't have big gaps when they leave the tapered end that they're driving down into the actual ground. So anyway, it's kind of some tips. The specifications may require thicker or longer electrodes and installation in specific configurations. So you might have an engineer who might say, I want 3 ground rods, or I want to have a 4/0 copper taken to my ground rod. Whereas the National Electrical Code tells us in 250.66A that it doesn't have to be larger than a 6 copper or 4 aluminum to a ground rod. But remember, specifications might require them to be much larger. Once you start getting larger, you're going to worry about how you're going to make that connection. It's probably going to require exothermic welding because clamps only go so big. Things that you have to think about, but again, they have to be 8 feet in length. Now, many specifications want them to be longer. IEEE recommends 10 feet and at least 10 feet apart. And sometimes people say 8 foot has to be 8 feet apart. But the code just says 8 feet long, 6 feet apart. And you're going to drive them below the moisture level. And they are supposed to be driven unless you hit rock. And then you can go at 45 degrees. And if you hit rock again, then you can dig down and put them down. And you can go down 2.5 feet and put them down at that point. So, there's other options that you can do. But you just need to be aware of all these things. Now, when it comes to rod and pipes, if you look at the graphic, and I'll explain it for those that are over in the podcast, we show a pipe or conduit, then we show 2 types of ground rods. Now, the pipe or conduit, again, it can be utilized. It has plenty of surface area, but it has to be a minimum of 3/4 trade size, and it has to be galvanized or equivalent to be in contact into the earth. Okay, so it has to have that sacrificial galvanization to it. Or it could be 2 different types of ground rods. One could be a non-listed stainless steel or copper or zinc coated steel, and that's probably what we see the most, zinc coated steel, but it has to be a minimum of 5/8 inch diameter. Now you're saying, wait a minute, I've seen some that are much smaller than that. Well, remember, these are non-listed stainless steel, copper, or zinc coated steel ground rods. We do have what's called listed ground rods, and they have a diameter that is actually less than 5/8 inch. But people refer to those as being 5/8 inch ground rods. But they'll have a mark on them, and it'll tell you that it's listed. And again, if you were to measure the diameter, it's going to be less than 5/8. But I'm saying, as long as it's listed, don't worry about it. Okay? You ain't got to worry about that it's less than 5/8. So don't get your caliper out and try to do this. Just look for the listing. That's all you're looking for. If it's unlisted, then, and manufacturers can make unlisted, then it has to be at least 5/8 inch diameter, at least a minimum. Whereas the listed ones actually can be marketed as 5/8 to meet the code, but they actually are less diameter. The difference is one has got a listing mark on it and one is not listed. Okay? And it is perfectly okay to use either. Okay, so just so you know. The next we're talking about is the A6, other listed electrodes. These are typical chemical rods, and for those that can't see the screen, they're actually a vessel. And they're required to be encapsulated, and they're encapsulated in ground enhancement material. Okay? And they go in, and the chemicals go in it, and it, in contact with the ground enhancement material, and what's also allowed is that it typically gets installed in a bed of bentonite clay, and you have an access well, and you actually will fill it, and it'll have a UL plate on it, and you'll fill it, and there'll be an actual factory pigtail on it that's connected for the connection to the conductor, and you have to fit. Now, these you have to maintain because they have to be replenished. I don't think I would use one of these unless I was in an area that really just could not give me a good connection to earth, and I need it for whatever reasons. Maybe I have a specific installation that has specified a certain level of ohms below, to be below a certain level, and I just couldn't achieve it. Maybe this will help you achieve it. And they make this the type that are vertical installation and horizontal installations. Okay? So these are they're other listed grounding electrodes. So they have other, and there might be others out there. And the reason we say other listed is because manufacturers can be very creative, and we don't want to confine them in this listing that they just can't be creative and come up with other avenues. But this is the typical one. For those that are watching in the video, this is typically what you would see. Those that are in the podcast, again, it is basically a copper vessel that's installed down in the ground. And it is, what you'll get is electrolytic roots that'll come out of the actual vessel, and it's in enhanced material that it's embedded in, and it goes down into the ground, and it has a well that you can actually open the cap and refill it. Okay, because you have to refill it. All right. Okay, so that's just the type of what's in it. The next one is 250.52A7. which is the plate electrodes. Now, plate electrodes, again, I do not see them an awful lot, although I do know that radio towers tend to have specifications that want these plates. And it's all about the surface area. So, let's talk about them. So, A7's dealing with the plate. If that's your flavor, you want to do that. It says, each plate electrode required to expose not less than 2 square feet to the exterior soil. Okay? Now, some interpret this rule as permitting a 12-inch square plate. Why? Because you have 12 by 12 is 1 foot on one side, and 12 by 12 is 1 foot on the other side. So overall, collectively, that's 2 square feet. Check with your local AHJ, because some of them might be so stringent that they say, no, I need to ensure one side is. So they might require an overly large plate in order to be able to make this earth connection. But I'm going to argue and say that, look, if the plate's stuck in the earth and it's 12 by 12, then I've got 1 foot on one side and 1 foot on the other, surface area-wise, I got 2 square feet in contact with the soil. But again, just be safe, and I say this many times, if in doubt, remember, your interpretation or what the code might say, doesn't always jive with what the inspector might think. So just keep those things in mind as you're moving forward, that you want to make sure that you're having that conversation with the inspector. Okay? Just want to make sure you're all on the same page. But this is just an example. Now, if it's a non-ferrous plate like copper, which is a non-ferrous, then it's a minimum of 0.0 inches thick. And if it is ferrous, like iron or steel, then it has to be a minimum of 1/4 inch thick, okay, or 0.25, however your flavor is. Now, installing these, you're going to follow the rules in dot 53. We're in the different types of electrodes in dot 52. When you get into dot 53, it starts talking about the installation requirements. And again, the installation rules for these are in 250.53a, b, e, and h that have to be followed. So if you're in and you attended our webinar, then you're more than familiar with what this is. If you haven't, then you're like, well, I don't know what A, B, and E, and H is. That's when you need to crack that code book open, pause this, and go look it up. All right, now, A8, which we didn't show as an example because we wanted to just discuss it. And again, this is going to be something you got to work out with your local jurisdiction. But A8 says other local metal underground systems or structures. And I encourage you to use caution here, because you might have a local, it means it's on-site piping system, underground tank, or maybe an underground metal well casings that are not effectively bonded to the metal water piping, so they're kind of isolated on their own. Then I could use those as an electrode, but you don't really know all the time the surface area. You don't always know it because it's in the ground. You need to check with your AHJ before you just assume that you can use A8. I know it says you can, but you do need to check it out, because again, some of them I've seen this through the country where they go, nope. In fact, I've seen people where they can't see the connection to the UFER, and they go, nope, I'm going to assume that it has a viscreen or a vapor barrier, and I'm not going to let you use it, and you got to use something else. Okay, and you go, well, it's right there. It says it on the drawings. It's in the construction drawings. So again, every AHJ will interpret things differently. So when you use A8, use caution, okay? Because you don't know what's there. You don't know if it's there. You're taking a leap of faith. You can use it, but again, when we say piping systems, we're not talking about underground metal water piping. This is some other piping system. Obviously, you can never use gas lines again, but at the end of the day, maybe I have a big metal underground tank. That's a lot of surface area, but you better check with your AHJ. I'm just saying, just a word of caution. That's why we didn't show it up front, A1 through A7. We saved A8 for this kind of saying, look, you might have something that's there that's local. Just be careful. All right. Now, what is not permitted? Important. What is not permitted to be used as an electrode? Now, this one can get people really confused, because the gas lines inside of a building, interior, they're required to be bonded because they're likely to become energized in some cases, or so we have to worry about those things. And of course, 250.104B gives us direction on that. And again, if it's a piece of equipment that has both a gas line coming to it and an electric power line coming to it with an equipment grounding conductor, then I can use the equipment grounding conductor in that circuit to suffice and meet this rule. So we do bond gas lines, and there's also CSST requirements that the gas people have to do. And unfortunately, as an electrician, we have to provide something for them because it's not in our code, but it's in their code. So there's things that we have to do. What we're talking about here is the metal underground gas piping that might be coming into the building that is outside the building. You cannot use that, even though it's metal, even though it's piping, even though it's in contact with the earth, probably 10 foot or more. It is not to be used as an electrode. Now, I know what you're saying. Yeah, but aren't we making a connection to it in the building? Yes, we are. It is what it is, folks. You have to make the connection inside because it's somebody likely to come in contact with it. And if you don't bond it, because when we say likely to become energized, it typically means that it's through a piece of equipment that has a mutual connection between the gas and the electric system, which a malfunction could cause it, theoretically, likely to become energized. Okay? So that's why we do the bonding on that. When it comes to the gas piping outside, no. Usually the outside piping is through unions and fittings and things like that is isolated. Just remember, we're not going to try to use the gas piping outside. Don't try to get into a mind meld in this. Do what the code says. It is what it is, and follow the rules. Okay? Don't use the metal underground gas piping outside as an electrode, and don't assume that it should be. Okay? Now, aluminum electrodes. Now, we have rules in the code that allow us to have the grounding electrode conductors to be aluminum or copper. Now, we have some restrictions for terminations within 18 inches of the earth when it comes to aluminum grounding electrode conductors, and we've had some changes in the 2020 code that allow you to come within 18 inches or less if it's terminated into a piece of equipment that's listed for the location. So we have some leeway, but for me and you, we're just talking all the electrodes that we just now talked about. Chances are they're going to make a connection that's probably going to be within 18 inches of the earth, and we can't use the grounding electrode conductor. The termination typically is not going to be within 18 inches of the earth without some of the caveats that have changed in the 2020. But here we're talking about using aluminum itself as an electrode, and we don't want to do that ever. Okay? The next, and I don't know nobody would even make one because they know that we can't do that. So makes sense, right? Now, the next bullet is the structure or structural reinforcing steel described in 680.26b1 and b2. All right, what this means is, if you're familiar with 680, this is swimming pools. Now, in swimming pool, you could have what's called B1 and B2, which is talking about the pool conductive shell and the equitential perimeter. Those are for a different purpose. They might look good. They might look like a lot of copper in the earth. They might look like a concrete encased electrode if it's rebar in the concrete that's making up the pool shell. Just because that might look like a great electrode, you are not to use it as an electrode. It doesn't matter if it's sitting there right next to the house, right near the service, and you're thinking, wow, I'm going to make a connection right there to that rebar in that pool because guess what? It's in contact with the earth and it looks like a concrete encased electrode. First of all, it's not a footer, so it's not going to meet the rules for a concrete encased electrode. And secondly, the code right here is saying you can't do it, so just don't do it. Okay? Simple enough, right? Now, 250.53, grounding electrode systems installations. Okay? Again, we can't cover all of those in this one today because, again, this is only an hour long. Hopefully you joined us on our webinar or you get the webinar recording and we're going to cover all these different things. Okay, so we're going to cover a few here and we'll probably get as far as we can on tonight's episode. 250.53, let's talk about the grounding electrode system installation. First things first, rod, pipes, and plate grounding electrodes are required to meet the requirements of A1 through A3. Okay, so now we're in 53, so we're talking about installation. What does it say? And you kind of heard me allude to it earlier. 250.53A1 requires them to be installed below the permanent moisture level. So do you know the permanent moisture level where you're driving your rods? Chances are you do not. And chances are an inspector's never failed you for it. Okay? So it says, though, where practicable, these electrodes are to be embedded below the permanent moisture level. It might be something that is not practical to do so. You might be in an area where the permanent moisture level is down 7 feet or 6 feet. It's not going to happen. It's not practical for me to put it down there. So you have to make an effort. You need to know where your water line is, permanent moisture level is. But I think that most people aren't going to give that really that much of a worry. But I will say this. Let's stop leaving the ground rods above ground. Why don't you dig out about a foot deep circle with your shovel, put the rod in the middle of it, drive it down, put the clamp on it before you drive it, and make your connection, put the dirt right there beside it. The inspector can come and look at it, and he'll see that it's below ground level. The clamp is going to be protected. It's not going to be above ground. It's going to get damaged or knocked loose. Use that as a common practice. That's a kind of a common sense approach. I don't know how many times I see it. Plus, if I'm an inspector and I see you, and I've seen this where they're sticking up 6 inches, then that's not 8 feet in contact with the earth. Okay? So again, you can say I'm being picky, but it's in the code. Just follow the code. It's pretty simple. Follow what it says. All right. Now, must be free from non-conductive coating. All right. So most of these ground rods are coated anyway with the zinc material or galvanization or copper. But if it's got any material on it, any coating, any wrap or anything at a certain portion, you need to take it off. Okay. It needs to make a good connection. Okay. And again, use listed clamps, whether it's acorn clamps or saddle clamps. Get them to make sure that they're listed for use with ground rods. And it might even be listed for ground rod and pipes, okay, like a pipe clamp. But just make sure you check the listing and also make sure that it has a DB on it for direct burial application when you're doing this. Now, the supplemental electrode requirement. This is interesting. That's why we'll at least cover this part in tonight's episode. This is a rule where you know that we supplement an underground water pipe. You're required to supplement an A1 electrode with any of the others that are available in A2 through A8. Okay? You can supplement. You can't supplement a water pipe ground electrode with another underground water pipe ground. I mean, that's common sense, right? Well, this is interesting because in this case, you drive a ground rod or pipe or plate, you have to supplement it with another electrode. Now, that doesn't necessarily mean that it has to be another ground rod. I can supplement a ground rod with a pipe or a ground rod with a plate, but I could also supplement a ground rod with another type of electrode. Now, it's kind of foolish to have a concrete encased electrode, which doesn't require any supplement at all. That's all you need. But I routinely see people have a ground concrete encased electrodes, and then the engineers or designers make them put a ground rod. Doesn't make sense to do so because you don't have to supplement a concrete encased electrode. But in ground rods, pipes, or plates, you're required to supplement. Okay, so here's what it says. It says a single rod, pipe, or plate electrode must be supplemented by an electrode of the type specified in 250.52A2 through A8. Now, most people are going to, obviously, if they're driving a ground rod, they're going to supplement it with another ground rod. You know, pretty much, why would you go to a pipe? Much harder to drive. And why would you dig it up and have to put a plate in? So if you're going to put ground rods in the first place, then you're going to have to supplement it. Okay? Now, the supplemental electrode is permitted to be bonded to one of the following. Now, remember, this is the additional one. So if I've got two ground rods, we're talking about you have the first ground rod, the single rod, which is your electrode. The additional one is the supplement electrode. Now, that supplement might be another rod, okay? But it could be any of the other electrodes in A2 through A8, right? If you want it. So, where do I connect that supplemental electrode? Whatever it may be, any of them from A2 to A8. And this is where people get confused. The supplemental electrode is permitted to be bonded to one of the following. Number one, it can be connected to the other pipe, plate, or plate electrode if they're what you're supplementing. Number two, the grounding electrode conductor that goes down to that single rod, pipe, or plate. So again, many people think that it has to be connected to the other rod. No, it can be connected over to the grounding electrode conductor itself. And it usually can be done with a typical split bolt. Remember, this is the supplemental electrode, okay? It's a bonding jumper that's going from that grounding electrode conductor over to this supplemental, if that's your design choice. It's probably the most people are going to do is they're going to go to the one rod and then jump to the other rod, and that's perfectly fine. But again, you have other options here. Number three, grounded service entrance conductor. Okay, so I could go from the panel down to the first ground rod, the single one, and now I have to supplement it. Well, let's say I want to go to a separate ground rod. Then I can go from the grounded service entrance conductor neutral bar out and down to a separate ground rod if I want. If that's what you want to do. I don't know why you do that, but you could. Code allows it. I'm probably going to just jump from the first rod to the next one, but you can if you want, okay? The third one says, again, we're talking about the supplemental. It says a non-flexible, that'd be like IMC, RMC, EMT, those type of thing. So a non-flexible grounded service raceway, remembering we meet all the bonding requirements in 250.90 and 92. Hopefully you've listened to that video or watched that podcast. I think I actually have an Electrician Live series. One of our shows was on that subject. So as long as you use the proper pipe clamp and you connect it to this non-flexible grounded service raceway and you follow all the rules of the bonding for service bonding, then I'm okay to take that supplemental electrode to that as well. And in number 5, it says to any grounded service enclosure. So as long as I take it up to the grounded service enclosure, guess what? If it's a main panel, it's got a main bonding jumper, and this is giving me the ability to take the supplemental electrode and take it right to a lug that's on the actual metal cabinet. I don't have to take it all the way back to the grounded service entrance conductor, right? This is the supplemental electrode. Quite interesting. Whereas the primary, I hate to use that term, but the ground rod to the first one has to be connected to the grounded service entrance conductor. That's the GEC. But the supplemental is not. That is a bonding jumper. And that can be taken straight up and connected to the enclosure where you have the service enclosure as long as everything is grounded and has the main bonding jumper and everything's done properly. Kind of interesting stuff if you think about it. And again, it can blow your mind if you're not familiar with all that. Now, there is an exception. So this rule requires you to have the one and you have to supplement it. Well, we have an exception that says, okay, you don't have to supplement a single rod, pipe, or plate if the resistance of that single rod, pipe, or plate is 25 ohms or less. Then a supplement grounding electrode is not required. Now, many years ago, it wasn't like that, okay? You'd put 2 in, and that was it. If one didn't qualify, put that. Here, you've got to put 2 in because you've got to supplement it with something else, and then you can take it away. You can take one away if it meets 25 ohms or less. And you can't do this measuring with an ohms meter. Okay, you need a ground resistance tester, a 3-point fall of potential tester system, or a clamp-on ground resistance tester. And they're not cheap, so it's probably cheaper to install just a second ground rod. I'm just saying, okay? But you can do it. And if you can show that it's 25 ohms or less, there you go. I don't need to supplement it with anything, okay? All right, now, again, that was dealing with the resistance of a rod, pipe, or ground plate, okay? Those are the 25 ohms or less. What's interesting is all the other ones, for those that are looking at the graphic, all the other one, there is no resistance requirement for grounding electrode system consisting of water pipe, the building's metal, the in-ground steel, the concrete encased electrode, or the ground ring. They have no ohms or less resistance application to them. The 25 ohms or less only applies to rods, pipes, and plates. So what's interesting is I only have to supplement rod, pipe, or plates starting out. And of course I have to supplement water pipe grounds, okay? Because it states that has to be supplemented. Other than that, building metal in-ground steel, encased or not, ground rings, concrete encased electrodes, for example, the chemical ones we talked about before, the other types that are listed, none of those have to be supplemented. Only the water pipe ground, and in this case, rod, pipes, and plates. Now, what's other interesting about this is even the water pipe ground doesn't have to meet 25 ohms or less. It just gets supplemented because the code requires it in case somebody removes it at a later date and replaces it with plastic. Now you've lost your electrode. But it doesn't have a 25 ohms on that either. It's only the rod, pipes, and plates that have this 25 ohms or less caveat to be able to only have one. Otherwise, you're going to have to supplement it with another type. And again, you got a list, but there you go. That's what you're dealing with. And of course, those that are looking at us on the video or watching the stream, you'll notice that I have on the screen a earth resistance tester. And you'll see the spikes that go in the ground, and you have to space them out a certain distance, and they're all connected together. And again, you can't do this with a normal voltmeter, ohm meter, ammeter. You have to use a specific piece of equipment. Now, these types that we show on the screen, which actually are physically done, are not all that expensive. Not all that expensive. In fact, AEMC makes one, and in our grounding and bonding course, we actually have supplemental material that shows you how these work, so you can learn what it's doing. These aren't overly expensive, a couple $100. Now, the clamp-on versions, they're expensive. Okay, $1,200, $1,500. I'd much rather drive a ground rod, a second ground rod, if that's the case with that. But maybe neat to have. If anybody out there wants to sponsor us and send me a free one, hey, I'll take a sponsor. But at the end of the day, probably. Now, for me, the limitation with the type that you actually put the probes in the ground is a lot of times on projects you don't have the space to get the distance to do the measurement. And so you're limited in space to be able to do an accurate test. So then that's a problem, and you can't do that. All right? So, now, let's talk about those multiple rods, pipes, and plates. So let's assume that we're going to supplement our rod, pipe, and plate. And in this case, we'll pick on the rod, and we're going to supplement it. Now, when I do supplement it, it has to be spaced no less than 6 feet apart. Okay? Can it be further than 6 feet? Absolutely. Again, there's a sphere of influence that comes out of these rods as it goes into the ground, as lightning or surge comes into it. And when I say surge is coming from high power lines that might be dropping on low power lines and things like that it makes contact with the earth. And you don't want the one sphere of influence for the one rod as it cones out to overlap the other and cancel out anything. You want it to be far enough apart. Now, in fact, IEEE believes that they should be the length apart based on the length of the rod. So if it's an 8-foot rod, they want them to be 8 feet apart. If it's a 10-foot rod, they want to be 10 feet apart. You with me? In order for those sphere of influence not to overlap and cause any possible cancellation on that. Okay? Now, the installation of additional electrodes. Now, here's interesting. If you install one, in order not to install a supplement for a rod, pipe, or plate, then you do a measurement, and if it's 25 ohms or less, you stop at 1. Now, let's say the ohms on that one is 10,000 ohms. I know I'm just throwing a number. And I install a second one because it's not less than 25 ohms, and now I take a measurement, and it's 9,000. It's still not below 25 ohms. Well, at this point, the code doesn't care. You did the 2, you're done, That's it. The 25 ohms was just to determine whether or not you had to supplement something. Once you add the second one or the supplemental electrode, then the 25 ohms doesn't matter anymore. That was the only rule for that application. Okay? Now, also, if you look at the illustration, and I'll talk those through the podcast, we show 2 ground rods in the ground. It says space the ground electrodes of a pipe or rods or plates not less than 6 feet apart. Okay? Space the rods so that there's no overlapping in the sphere of influence. Okay? And it is recommended to space the rods not less than twice the length of the longest rod. Okay? So there are other standards that say if it's an 8-foot, then they should be 16 feet apart. I have read it both ways. I have seen people that say it should be separated the length of the rod at least. All I'm telling you, that's all great information. That's all wonderful. But what's important to us is that they have to be at least 6 feet apart. At least. Okay? So, now interesting enough, people ask me this question. Does the grounding electrode conductor that goes down to the first rod, which is your electrode, does that have to be continuous to the second electrode if you're doing like 2 ground rods? And the answer is no. Now, can you do that to save connectors? Absolutely. But I could go to the first electrode, which is your electrode. That is your grounding electrode. The first one is. The second one is a supplemental electrode. So from the first ground rod to the second ground rod, that's a bonding jumper. Okay? It's different. That's not a grounding electrode conductor. So to the one that's coming from the panel down to the first ground rod, that is your electrode. Now, of course, when they're connected together, they're all a single electrode. But when it comes to these rules, it has to be unbroken to the electrode. Now, we have some allowances for exothermic welding, irreversible crimp, and things like that. But I want you to remember, the portion that is the grounding electrode conductor comes to that first electrode. You don't have to pass through the connector onto the second electrode. You can stop at that electrode, then put a second clamp on there, and then have a bonding jumper over to the second electrode if you want. That is perfectly acceptable. Now, in our graphic, we show 2 clamps, one coming in with the grounding electrode conductor, looping through it, and going to the second one. Well, you just saved yourself a clamp. Because if I did if I stopped it at the first ground rod, that clamp can only have one conductor under that clamp. Then I would add a second clamp to go over from there over to the second ground rod. So again, when would you do this? Maybe you don't want to install the connection between the first one to the second one just yet. I don't know. And you're not going to put enough copper because you're afraid somebody will steal it. So maybe you give enough to go down to the first electrode, and then you wait before you make the connection from the first one to the second one. I don't know. It's up to you to do this. But me, if I ever did this, I am just going to make sure I have a long enough grounding electroconductor to go all the way to the end. Why? Because it saves me a clamp. So to each his own. All right. So again, we're not going to get into the mathematics that is engineering, as it's unnecessary, because this talks about spacing of rods and things like that. We will talk about that on our webinar, but we're not going to get into that. Now, 250.52A4 rod, pipe, and plate electrodes. I want to finish up on this because, again, we're past our hour for our Electrician Live. The rod or pipe electrodes, they have to be at least 8 feet in contact with the soil, okay? Fully in contact with the soil. They have to be driven, okay? If you encounter a rock, then you're allowed to do it at a maximum of a 45-degree angle. If you hit rock again, then you're allowed to dig a trench and bury it 2.5 feet deep. It's permitted to do that. You can't do that right away. You got to try to drive it. Okay, it's that connection and that compaction of this earth with that rod is what makes that nice connection to the earth. But again, you have some options. You can't just jump straight to the burial in the earth. Okay, you have to try driving it. Then when you hit rock, you can go to a 45. If you still hit rock, then you can go to the trench. Now, you still have to keep them 6 feet apart minimum. So even if you did a trench, your trench is going to have to be adequate enough to keep the rods at least 6 feet apart. Okay, so don't forget, you still have those rules you have to follow. Okay, all right. Now, as far as clamps, again, listed clamps are required. I've told you they got to be suitable for rod or pipe. They have to be listed for direct burial. They're typically going to have a DB marking on it, and usually those with the DB marking are also suitable for concrete encasement connections as well. Always, whenever in doubt, you want to check with the manufacturer, and it's a very quick call. It's very easy to get the cut sheet information from the products, okay? But just to make sure, all right? So anyway, that's what we're going to cover in that tonight on Electrician Live. Hopefully you got something out of that. It's if you ever get a chance to get our grounding and bonding series, where we go into it extremely deep, and there's a lot of questions and in-review questions and a lot of graphics, you'll get a lot from it. It's a very good series. If you ever get a chance to attend one of our webinars, check it out. We just did one on grounding electrode systems and grounding electrodes. Pretty cool. Covered a lot of information, answered a lot of questions. So hopefully you'll check that out. So hopefully you enjoyed tonight's episode. You learned a little bit about grounding electrode systems, but mainly about the electrodes. And again, we covered what we could cover, but maybe we'll touch this subject again at another time. Till next time, folks, stay safe and God bless.
You've been listening to Electrician Live with your host, Paul Abernathy.